And now we're going to talk about what makes an API a REST API. In order to make this session shorter, we're going to break it down into 3 parts. In this first part, we're going to talk about the uniform interface constraint. The first rule says, resources are identified by a universal resource identifier. So this resource is identified by this URI, this other resource is identified by this other URI. If these resources share a common path, this common path is known as the resource collection. Just a note here, resources are made of attributes and links. We're going to talk about that later on. But if you think about it, this rule is telling us that this API is actually a representational API. The client does not have access to the details of how this database is built. It only has access to these resources through a representation of them through URIs. The next rule says, with a resource identified, a client can modify it or delete it at the server. In real scenarios, the client must have the appropriate permissions in order to do so, or what we call authorization. This rule means that if you are coding a REST API server, you must support put, patch, and delete. And if you're coding a client, you can rest assured that your server is going to support put, or patch, or delete. So you can use that as your method for your HTTP request. Don't forget to identify your resource within your URI field within your HTTP request as well. The next rule says, each message contains enough information to perform a single action. By single action, we mean an HTTP request responded by a single HTTP response. The client has enough fields within an HTTP request to send enough information to the server, for instance, the method, the URI, headers, and body. A single action may have 2 outcomes. It may be either a success, in that case we are going to receive something like this, or it may be a failure due to lack of information being sent from the client to the server. In that case we are going to receive something like this. So if the outcome of this first action was a failure, the client may try again, but this new try is a completely new, different action. So this new action cannot reference the previous action whatsoever, as the server that replied the previous action is going to actually forget about it altogether. This is actually established in another constraint, so this new action cannot reference the previous action. It's a completely new independent action. And given this second action is completely independent from the previous one, then I can have an independent different server replying to this second action. We can make this work if we use, for instance, load balancers between clients and servers. So we can have independent servers serving independent actions. This rule makes REST APIs highly scalable. The full rule says the server must provide hyperlinks in responses to discover other actions. So first of all, this rule says that the REST API server must support the GET operation on a particular URI. And within the HTTP response, the REST API server is going to send attributes, but also it is going to send links. So our resources are not simple data structures. By sending links, we can perform actions on this data structure. So this resource becomes an interactive object. This is known as hypermedia as the engine of application state. So these 4 rules make what we call the uniform interface constraint. The first rule says that we are going to only be able to access to server resources through a representation of these through URIs. The second rule says that we can work with put, patch, and delete. The third rule says that we are going to interact with servers with a single HTTP request and a single HTTP response. We can always send a new HTTP request, but this represents a new different independent action. And the fourth rule says that we are going to support the GET operation, where we can retrieve attributes and links for specific resources. Finally, if we think about it, the name uniform interface is highly adequate because it establishes that any single REST API client is going to interact in the same way with every single REST API server, with a single action, with a set of supported methods such as GET, PUT, patch, delete, and identifying resources through URIs.